In this video, we look more closely into an advanced feature of automation services called context configuration. In order to understand this TaaS framework concept, we need a more detailed discussion and some more complex examples. In this first part, we focus on some general explanations and the first example of a three-tier application. Another video will present the second example, including REST services. Interactive demonstrations will show some of the context configuration features based on sample implementations. In the TaaS framework, the automation services support two kinds of node configuration steps. Standalone configuration takes into account nothing else than the node itself. A typical example would be to register a model-specified log file path with the provisioned node's local logging system. On the other hand, context configuration handles all those setup tasks that require knowledge of the topology context a provisioned node is running in. A common example often cited is the setup of a target server address pool in a load balancer. While this is often a specially implemented case, there are many more cases in enterprise infrastructure or applications where the dynamically created environment must be known in order to set up a node correctly. Examples are database or REST service URL injections into applications. In the TaaS framework, all these cases are handled within the same abstracted concept of context configuration. It is important to note that only after those setup steps, an application can be immediately operational right after an automation service successfully ends. Delivering fully working infrastructure and applications is the main purpose of TaaS. Applications should never have to take configuration steps themselves. Let's look at some definitions that will be needed to understand the inner workings of context configuration in TaaS. First, there are so-called context configuration dependencies. Such a dependency implies that a certain node must have reached a certain state, where that state represents the successful execution of a step in an automation service. Context configuration of a node can only be started when all the node's dependencies are fulfilled. We will look at some examples of such dependencies soon. And then there are remote commands. This is basically a path name of a command file plus arguments that needs to be executed on a provisioned node in a topology instance by the framework. The entire orchestration of context configuration happens within the TaaS framework's automation services. The services use the topology model and the context configuration dependencies to derive which nodes need to be touched, either to be freshly configured in context or to be reconfigured after a previously executed service. It is also decided how that should happen and in which order. The framework relies on support by a node's customization realm, which has to provide details like the realm-specific dependencies only the realm can know about. The realm also must take care of the actual product-specific configuration work on the provisioned node, either by executing that work directly or by providing a set of remote commands that will then be executed by the framework in due time. The first example is a simple three-tier Java EE application with a load balancer in front, HTTPS connection to an elastic web tier that receives during deployment a servlet, from where an EJB connection goes out to EJBs in a cluster to which EJBs are deployed during deployment. And finally, a JDBC connection from the EJB to a PostgreSQL database. The steps that need to happen for adding a context configuration during provisioning are per node outlined here. Note there is also a remove context operation, of course, that might be called when a scale down happens in a topology node or when a node is replaced. So the load balancer from the network realm has a list of dependencies of every outgoing HTTPS connection's destination nodes that the OS layer there must be ready. That's needed because during the context configuration, the pool of target services is set up in a way that the virtual server will actually trigger a ping to the targets to check that things are working. Note, the virtual server was set up during node instantiation. It's a shared node, so the instantiation of the shared node, in this case, actually creates the virtual server within the shared load balancer. Then in the Java EE presentation tier nodes from the JE realm, the dependencies are that every outgoing EJB connection's destination node must be instantiated. That's needed so that the dynamically generated host names are known. Because in the context configuration step, then, we need to set up the JNDI tree in a foreign JNDI provider setup to extend the namespace to these destination nodes. And finally, in the Java EE business tier nodes, we don't have to do anything at provisioning time because the actual full database URLs are only available once the application's deployment artifacts are known. So we will look at that again during deployment configuration, which happens here. Let's first look at the actual code of the application, how simple it is to use EJBs within the Java Enterprise Standard. So the servlet, that is the EJB client, adds an annotation with a lookup string to a bean that fulfills the interface that was given by the EJB. In this case, the lookup string is ping EJB, and the service API is the ping service, and it has a method that is called ping. The EJB implementation, on the other hand, publishes its name, its portable lookup string in its node's JNDI tree, or its server's JNDI tree, and in order to be able to call the database, injects the data source reference as a DB client. So in this particular case, the lookup string is again ping EJB that will be entered into the local JNDI tree. The class implements the ping service, and it has in its definitions or declarations at the beginning that it is injecting a resource with the name TaaSFW, which is the name of the table in the database that it's going to call, and that's the data source. So that's the regular injection for data sources. Now, if you look at what needs to happen in the various nodes of the topology, in this case, the load balancer doesn't have to do anything. It's not involved in deployment. The Java EE presentation tier nodes, on the other hand, they have outgoing EJB connections, and their destination nodes must have their deployment artifacts installed so that the EJB's lookup strings are published in the JNDI tree. That's the dependencies that we have there. And the actual context configuration will take this information by executing a remote commands to set up the JNDI links in the node's Java EE server. Node 1, the JNDI tree of the source, was extended to the destination during provisioning, as we saw before. Node 2, in our example customization that we did here, the lookup string is found by parsing the deployment artifact that is deployed and looking for the annotations in there. But it could also be set, and that's supported as well, it could be set as a custom property in the deployment unit. In the Java EE business tier nodes, the dependencies relate to the database. So every outgoing JDBC connection's destination node must be ready so that the database connection will work. And the work that has to be done during context configuration is again handled with remote commands that actually set up the database URLs in the data sources in the Java EE server on the node for every database reached. Node 1, in the example customization that we did here, the resource name for the database URL is found by parsing the deployment artifact, or it can also be set as custom property in the deployment unit, similar to what we saw with the EJB lookup strings. Currently, however, we are only using a predefined test database table that's already installed in the target database. Node 2, the port for the database URL is found in the custom property of the database node itself. It is published there by the database realm. In order to demonstrate the context configuration within Topology as a Service framework, we have to dig a little deeper and look at a bit more complicated examples. Here we take a 3-tier application in the Java Enterprise realm with a load balancer in front that talks via HTTPS to a presentation tier or the nodes within that elastic tier. The nodes in there talk themselves through the EJB protocol to the nodes within the EJB cluster, and these nodes themselves again talk via JDBC to a database. So if we provision that, let's add a little bit scalability, at least to the presentation node bit tier. 2 initial nodes and provision. So the task gets started, that's fine. What has to happen now during provisioning time in terms of context configuration is the following. The load balancer has to set up in its pool of the newly created virtual server in the shared load balancer the names of the newly created nodes in the web tier. So for that, at least they must be instantiated so that the names are known. The dependencies reflect that. Within the nodes of the web tier, we need to know the EJB nodes that they are talking to in order to set up a foreign JNDI provider, set up the JNDI tree, the common JNDI tree between the web tier nodes and the EJB cluster nodes. And finally, in order to find the database that has been dynamically created on a node, we need to know the URL inside the EJB nodes. The full database URL with all the relevant parts can only be constructed once the application's deployment artifacts are known. So we'll look at that during deployment again. Provisioning, including context configuration, has happened already. So there was 4 VMs and the virtual server set up in the load balancer took 55 seconds. That's okay. Let's now deploy a simple application to that infrastructure. That JNDI ping example does not much more than just send a ping from the server that's deployed on the presentation tier to the EJBs that are deployed in the EJB cluster, which themselves will talk to the database. Let's deploy that. with the default settings. Task is started, things happen in parallel as much as possible. What has to be set up now in terms of context configuration is that within the WAR file, we find the name of the EJB it wants to talk to through injection. That means within the nodes that this WAR file is deployed to, we have to set up a JNDI link on the already existing foreign JNDI provided to the EJB node that reflects the EJB that we want to talk to. On the EJB servers, the name of the EJB is automatically added to the local JNDI tree because the annotation said so in the application. That means we should have now, after this deployment, a fully running application. Let's check that out and call it on the default port. We see the servlet gets called, tells us on which host it is running, and it shows us the answer of the EJB that it has been calling through the service API, the method ping. The EJB answers by telling us on which node it is running and a quick select now on the database to show us that the URL was set correctly and we get an answer from the database. A second count to statefully count the calls to the EJB delivers 1. So if we call it again, first it went to the web node, second it goes to the clone 1, the second node that we have in the presentation tier, and the ping count goes up to 2. So let's look now at a operation that we could execute at runtime with that setup. So for example, the clone 1 could have a problem, or we just want to test that the replacement really works, and we go ahead and replace that node. So what has to happen now, the old existing clone 1 node has to be deleted, including all the side effects that were happening during context configuration in the first place. That means taking out the entry in the pool of the load balancer, in this case. Then a new node is created that goes into that elastic tier, and its context configuration during provisioning has to happen again, meaning the JNDI tree gets set up in the load balancer and an entry is added to the pool. And finally, the WAR file with the servlet is deployed again to that new node, which triggers a JNDI link setup for that to the EJB node in the new server. So let's look if that has actually worked. Right now we see the old clone 1 that was reached 7803 at the end. So if we reload, we get to the old web node again. Ping count goes to 3, and the next reload should actually go to the new clone 1. It has 4660 at the end, so that's a new one. Ping count went up to 4, meaning the entire other setup was still working and was around. Nothing had to be done, but the new presentation tier node was added. The replacement took 40 seconds, the deployment, by the way, 8 seconds. So once we're done, as usual, we delete the instance to clean everything up. That's a very fast synchronous operation, and the side effects are gone.